Welcome to this video on graphing exponential equations. By the end of this video, you should be able to do multiple things with exponential functions, such as define the parts of a graph, locate and identify the asymptote, the y-intercept, tell me if the exponential graph is increasing or decreasing, identify the domain and range, find the x-intercept, and tell me the rate of change over a given interval. All right, so there's some vocabulary to get us started. What we're talking about is exponential functions. So an exponential function is a function whose successive output values are related by a constant ratio, meaning they're multiplying instead of adding the same value each time. You're multiplying by the same value each time. And when we look at the equation, you can see multiplication taking place in here. Okay, so this is our most basic exponential function, y equals a times b raised to the x. Now notice our variable is in the exponent. Whenever you have an x in the exponent, it's an exponential function. Okay, in this form, a, b, and x are real numbers. A cannot be 0, b has to be greater than 1, and b cannot equal 1. Okay, so every exponential function has an asymptote. This is one of my favorite math words, the asymptote. The asymptote is a line on the graph that the graph approaches, but it never, ever touches. It's kind of like, almost like an electrical fence. You can get really, really close to it, but you're never going to touch it, okay? Now, when our exponential function moves away from the asymptote, and this is always when we're moving left to right, if it's moving away when you go left to right, we call that growth. You can tell it's going to be growth if your b value, if this value right here is greater than 1, it's a growth, and the graph will increase from left to right. If the exponential function moves towards the asymptote, meaning as you're going left to right, it's getting closer to the asymptote, that means we're going to call that a decay. Okay, the b value will be between 0 and 1, and the graph will decrease as it moves from left to right. So that's just kind of some vocabulary to get us started. Okay, so a growth, if we had our coordinate plane, will move away from the asymptote, meaning it's going to start lower and then it's going to grow up, kind of like you did. Start small and get big. Okay, a decay goes towards the asymptote as it goes left to right. So it's going to start big and it's going to shrink as it's going to come down by the asymptote as it goes left to right. Okay, growth starts small, gets big. Decay starts big, gets small. All right, parts of our graph that will help us while we're doing our exponential functions. So overall, this is an exponential function. Okay, the actual graph, we call that the exponential curve. All right, right here, we've done this point before. That's where the graph crosses the y-axis, so that's our y-intercept. And this dotted line, see over here how the graph is getting really, really close to it? The graph will never cross that. That's our asymptote. Now, often the dotted line is not there. That's part of what we have to work on to help us identify it and determine what the asymptote is. Okay, so first we're going to try these problems. We're going to need Desmos, so pause the video and pull Desmos out and come back when you're ready. All right, so I have some equations here. We're going to put these equations into Desmos. So let me open up Desmos, and my first equation said, f of x equals 3 parenthesis 2, close your parenthesis, put your x in the exponent, plus 4. So make sure, it looks like I got a little bit off over here. So let me, f of x, there we go. Okay, so f of x equals 3 times 2 to the x plus 4. That looks just like our equation. Now, I want to know the y-intercept here. So remember, the y-intercept is where the graph crosses or touches the y-axis. So I got to move my graph down a little bit. Here's my y-axis. So I'm just going to hover, and it says it's going to cross the y-intercept at 0, 7. Okay, so my y-intercept is at 0, 7. Okay, and then my asymptote. So let's go back and look at this and see if we can figure out what the asymptote is. All right, so the graph, we can see it's getting closer and flattening out over here. So it's approaching a line, and I'm going to look, and it's never going past this 4 line. I could keep going and going and going. It's never going past that line. Now it looks like it's straight flat on top of it. So what we're going to say is our asymptote is at y equals 4. Okay, so let's try this again. We want to find our y-intercept and our asymptote. Okay, for 2 to the x minus 3. So let me open up Desmos. And so you don't even have to put the f of x part. We can say 2 raised to the x minus 3. Make sure it matches what your equation says on your paper. Okay, and I got to start moving my graph around so I can kind of see it. All right, so what I was interested in was my y-intercept, which is down here at 0, -2. Okay, and I wanted to know about the asymptote. So let's see if we can figure out what that asymptote is by looking at this graph. It comes down and it gets really flat out here. So I'm just going to follow this back across, and that looks like -3. Okay, so let's put that our y equals -3, our asymptote. So this is really the equation of the line of the asymptote. The graph is going to get really close to where y is -3, but it's not ever going to cross it or touch it. All right, let's try this 2 more times and see if we see any pattern. So we're going to put this number 3 into Desmos. Okay, so we have 2 times 3 to the x, 2 times 3 to the x. Okay, and then plus 4. So plus 4. So let's take a look. I'm going to move around a little bit. We want our y-intercept. Well, that's right there. You can see it's at 0, 6. Oh, sorry, it's plus 1. Let's change that. It's just plus 1. 2 to the 3x plus 1. There we go. There's our y-intercept. Is at 0, 3. And then our asymptote, take a look. It's really flat out here, so I'm just going to follow that straight across until I get to my y-axis at 1. So I'm going to say y equals 1. And one last time, go ahead and try this one all on your own and see how you do. All right, for number 4, I got the y-intercept was 0.5, so it'd be at 0, 0.5. And that my asymptote was at where y equals 0. Okay, so just to double check to make sure your graph, we had a y-intercept of 0.5, and then we can see how flat this graph is, and we just followed across. Y is 0 here. We don't want the x value, we want the y value. All right, so let's take a look at this real quick. Do you notice anything? Any pattern? What I notice is this number added to the end looks to be the same as my asymptote. Look, I subtracted 3 here, and look what my asymptote was, -3. I added 1, and my asymptote was a positive 1. Here, I didn't add or subtract anything. There was nothing out there, and my asymptote was 0. So the number on the end, adding or subtracting, is your asymptote. It helps you identify it. All right, let's try some characteristics that we've talked about previously and apply them to exponential functions. All right, for these, we're going to identify these characteristics that we've talked about previously. We're adding in asymptote, and growth and decay are neither. Remember, growth and decay, growth is it gets bigger as it goes left to right, decay is it gets smaller, and I'll show you what neither looks like when we get there. So when we look at this graph, we're going to kind of sketch in our asymptote and our y-intercept and then sketch our graph to match. All right, so when I put in 2 to the x, I get this equation. So my y-intercept is 0, 1. So on my graph, my y-intercept is at 0, 1. Okay, and then if you didn't notice, there's nothing adding or subtracting out here, so that means my asymptote is right here. The x-axis is my asymptote. Okay, and then our graph started low on this side and came up through our y-intercept and then went off. Be sure to go ahead and put your arrows on the end. So that's just a quick sketch of what our graph looked like. Okay, so growth, remember, is it starts small and gets big, and decay is it starts big and gets small. This one starts small and gets big. This is a growth. It is, because it's getting bigger as it goes left to right, it is increasing. Okay, your asymptote is here. Your y value at that point is 0. So we're going to say our asymptote is y equals 0. The domain, remember that's your x values left to right. The x values will never stop going left. They're never going to stop going right. So our domain here is all real numbers. For our range, remember range is y value. Well, the asymptote is stopping this graph from going down any further. It will never go past this red line. So that means all of our y values have to be above that red line. They can't go below it because of where the graph is located. So all of my y values are going to be greater than 0. But they can't be equal to 0 because the asymptote can never be touched. So we're going to just say any y value, if it's going to be on the graph, has to be greater than 0. Our y-intercept, we identified it right there. It was 0, 1. Our x-intercept, well, the x-axis is the asymptote. The graph can never touch the asymptote, so there cannot be an x-intercept. And finally, our rate of change, remember rate of change is slope, and I'm giving it over a particular interval. That means if you look, there's an x value here. That means I'm giving you the x value of 2 different points. So I'm going to show you a quick way to check this out. I'm going to pull Desmos back up. This is our graph. I'm going to hit the setting wheels right here. And then I'm going to pick this table. And the table will show me points that are on my graph. And for my rate of change interval, I had wanted to know when x was 0. So I'm going to look at my table. When x is 0, the y value there is 1. So I have 0, 1 is one of the points. I got the 0 from right here. The other x value I asked about was 2. So when I look at my table of values, if x is 2, y is 4. So that's the second point. Okay, then our slope is, remember, y minus y divided by x minus x. So I'm going to say 4 minus 1 divided by 2 minus 0. 4 minus 1 is 3, 2 minus 0 is 2. So the slope on this particular interval is 3 over 2. Okay, that was a lot. Most of it was review. Let's try this again and see how we do. All right, so if we put this equation into Desmos, we want to identify some important characteristics. So let's look at Desmos. I have a y-intercept of 0, 3, so I'm going to mark that on my coordinate plane because that's going to help me do a quick sketch of the graph. I have an x-intercept. You see right there, it's crossing the x-axis at 2, 0, so I'm going to mark that on my coordinate plane. And when I look at the graph, see how flat it is? I'm going to follow that across. We're not going to go past where y is -1. Okay? So let's take a look kind of what this is looking like. So I put in my y-intercept, I put in my x-intercept, and I put in my asymptote. And so I'm just going to make my graph. It came from above up here. It came through these 2 points, and then it's going to ride along my asymptote and not pass it. Okay, so that's just a quick sketch of our graph. So now growth, decay, or neither. Growth starts small and gets big, decay starts big and gets small, and neither we'll deal with in just a minute. This is a decay. It starts bigger and gets smaller. It's approaching the asymptote as it goes left to right. So this is a decay. Notice our B value is between 0 and 1. We talked about that at the beginning. That's our B value. So as the graph goes left to right, it's decreasing. Our asymptote, we already sketched it in. It was here where y was -1. And if we check, look, it says -1 on the end, so that tells us what our asymptote is. Our domain, we have arrows on both ends. It's not stopping left to right, so that means all real numbers. Our range, the whole graph is above the asymptote for our range. So that means all of my y values have to be greater than the asymptote, which is -1. Remember, you can't touch the asymptote, so we are not going to use equal to, it's just greater than. Our y-intercept was 0, 3. Our x-intercept was 2, 0. Okay, so most of that we just doing our quick sketch, we were able to answer a bunch of the questions like this. Now our rate of change, remember I'm looking for 2 points, one where x is -1 and one where x is 2. So let's pull back up our Desmos, go to the settings wheel and pick the table of values. And if x is -1, the y value there is 7. And if x is 2, the y value there is 0. And that gives us our 2 points. Once we have our 2 points, we use our slope formula, which is y minus y divided by x minus x. Okay. So 0 minus 7 is -7. And then I have 2 minus -1. That actually turns into a positive. So 2 plus 1 is 3. So the slope of the line between those 2 points is -7 over 3. All right. One last one. Go ahead and put this into Desmos and see what you can get. All right, here's your equation, -3 times 2 raised to the x plus 1. So I'm going to sketch in my important numbers. My y-intercept is at 0, -2. My x-intercept, it's kind of weird, so I'm just going to find it here. It's -1.58, comma 0. Okay. And then my asymptote, it says +1 here on the end of the equation, and if you look, that's where the graph flattens out, where y is 1. So that's where y is 1. Okay, so my graph, you remember, came along this asymptote, and then it came through the x-axis and through the y-axis, and then kept going down. So this guy was different than the other ones. The other ones were above the asymptote. This one is below the asymptote. So when you're below the asymptote, you are neither growth or decay. So we're going to circle neither here. Okay. We can still answer this question. As we go left to right, we're going down, so we're decreasing. Our asymptote, we already said it's right there at y equals 1. Okay. Our domain, we're not stopping left to right, so that's called all real numbers. Okay, so our range here is all of the graph is underneath our asymptote. That means our range has to be less than the asymptote. So all of your y values are going to be less than our asymptote, which is 1. The y-intercept, we marked that. That was 0, -2. The x-intercept, that was that weird one, -1.580. And our rate of change, okay, so let's pull up our graph and get our table of values off of this. Our rate of change is between where x is 0, so if x is 0, my y value is -2. And if my x value is 2, my y value is -11. And remember, we're getting these x values from our interval. It's telling us the x value of the point. We find the y, and you say y minus y divided by x minus x. Remember that minus minus becomes a positive, so negative 11 plus 2 is negative 9. 2 minus 0 is 2, so the slope of the line between those 2 points is negative 9 over 2. Let me know if you have any questions. See you in class.